For designing a PCB which you will be making at home, you need to keep in mind these few things. The first is the design transfer method, which is the method you will use to transfer the design to the PCB. The second is the etching process you will be using, which means whether you use HCl and H2O2 for the etching or whether you use ferric chloride for the etching. Different methods can provide some differences in the etching process which will affect our design. The third is the drill size, which means the size of the drill bit you will use for drilling out the holes for the THT components on your PCB. I use this Express PCB software because it allows great control over all these three things I mentioned before. So let's get started. Firstly, we will visit the Express PCB website, and when it opens, we will click on Download Plus. It won't start the download, we will have to provide our email address, then we will receive an email. In the email, they send us the specification of the software about what it can do, and there is also a download button here. So when we click it, our download of the software will start. After the software has been downloaded, you can open up the zip file and install your software. As you can notice, the software will look a lot different in my video than when you first install it, because I have changed a little viewing colors for my liking, but it won't make any difference in the designing process. The first thing that we will do is increase the thickness of the board's edge. To do that, we will just click on the edge. It will select the whole board, and then on the top left corner there is a section named shape. We will just adjust the thickness from there. Now as we can see, the board line is pretty thick. The next thing that we have to do is go into the grid section and select grid and snap spacing. Then in the grid part, put 2.54 mm, and in the snap section, put 1.27 mm. What this will do is adjust the spacing between these dots we can see on the screen to be exactly 2.54 mm. If you are thinking why did we set it to 2.54 mm, then 2.54 mm is the industry standard for pin spacing in electronics. 2.54 mm is also 0.1 inch. Now let's see how to change the size of the hole. So if we select the hole and go up into the holes and pads section, we can see there are two separate boxes in which we can put values. So in the first box we will put 2 mm, and in the second box we will put 1.2 mm. The second box represents the inner diameter of the hole. I have set the inner diameter to be just above 1 mm, which is also my drill size. Similarly, if you are using any different sized drill bit, then you can change these settings to your liking. Now let's design a circuit. We can go into the parts section and select choose part from library, and we can see there are multiple libraries available. When you first start the program, you won't see many of the libraries which will be visible in my software, because I have made those libraries myself. I will also show you how you can make your own parts libraries in future videos. From the parts library, I picked this DIP 8-pin IC and pressed F8 on my keyboard. That enables the pin notations. I will design a simple circuit based around the 555 IC. So what I can do is, to simplify my designing process, I can name the individual pins of the ICs. For example, pin number 1 of the 555 is ground, and pin number 2 is trigger, pin number 3 is output, and henceforth all the pins can be named. This will help us in the designing process because we won't have to be looking into the circuit diagram or the pinout of the IC to know which pin does what. Now after I have named all the pins, I will select this IC and go up into the part description and name it as 555. After the IC, we will go into the part section again. We will find resistor, and in the resistors category, we will search for resistor quarter watt 0.3 inch and we will place it on the PCB. We selected 0.3 inches because a standard quarter watt resistor like this has a pin spacing of 0.3 inches. Now we will just change the whole size of the new part which we have just selected, which will meet our requirements. For example, 2 mm and 1.2 mm in the whole section. If we want to rotate the component counterclockwise or clockwise, or mirror the component or do any sort of things, we can use the arrange section in the top. I will select the component and in the part description change the resistor part to its value. So by doing this, we can know exactly what value resistance we are using in the circuit. Now after the resistor, we can once again go into the parts library, and in the capacitor category we can select the capacitor 0.1 inches. Because my capacitor is an 100 microfarad 25 volt electrolytic capacitor, I will use this polarized one. Once again, after placing the capacitor, we will change its hole size just like we did with the resistor, and then we can start with the designing. Now we have to look into the circuit diagram to know which component connects to where exactly. Now after we have the circuit diagram with us, we need to lay down the traces. Now when we start forming the trace, we can see it is in red color, which means top copper. We can go into the shape section and change it to the bottom copper, because if we want to make the PCB at home, we have to set it on bottom. Now we can start laying the traces down. We can just click on the pin and click on the other pin and the trace will be laid. Now I cannot narrate the whole PCB designing process, but basically what it is practice. We need to know where exactly the connections will be, and we need to know how to connect those places together with these copper lines. Basically these traces are just copper lines on a 2D image, right? A copper clad board is a 2D frame, and in that frame we are laying down these copper lines which will electrically connect to each other, and which will electrically connect the pins or the pin of an resistor to a pin of an IC, etc. And basically this will complete the circuit. So we need to figure out how we will design this circuit into an 2D image. Now when we are done designing the PCB, we can notice our PCB is way shorter than the board edge is. So what I do is I zoom out and select the whole designed PCB like this, and then I drag it to one corner of the board edge. I almost forgot, we need two more pins. The first is the power input and the second is the ground input. So basically these two pins will provide power to our entire PCB. So for the positive VCC, I just make a round hole, normal hole, and for the ground I will make a square hole. So just to identify those. We can also go into the text menu and we can add these ground and VCC symbols. If you'll notice, the VCC is mirrored because we are looking at the board from the top side. If we flip over the board, we can see the bottom side where we have laid all the tracks and where the VCC will be written. After that, it's time to resize the board. So what I do is, I click on one side of the board and drag it down till it reaches the board design. Similarly, from the right side, I will select it and drag it till it fits my whole design. So basically our PCB design is done. If you want to know how big this design is, we can just simply click on the edge, and in the top size and position menu, we can see the width and the height of the design. Now for transferring this design to a copper PCB, we will have to print it out. So let's go into the print menu, and we can see there are multiple options here. We can print this design for just proofing that our IC or components fit into the design, but we will just go into the transfer H menu and click on print. We can click on the Microsoft Print to PDF printer. So what it will do is, it will make a PDF out of it. So after we save the file, I will just name it as test, and after we save it, we can open it up and we can see that the design is ready. The printout is automatically mirrored for transferring it to the copper board, so we don't have to repeat that process. If you liked the video, then do give it a like, share the video and subscribe to Jitulex.